In this video I'm going to tackle what will probably be the more technically difficult repair on this bike, and that is the right hand side mid fairing, as I discussed in the part 1 video. So this video I'm going to take you through that repair, and if the repair is successful and we're happy enough with it, then we'll detail out the rest of the panel and the left hand side panel as well. For this repair I'll be using a donor panel from Erect CBR. This panel is not repairable, so we'll be able to use this as a donor for the part that is missing from the panel we're repairing. I have a plastic welding kit, some ABS plastic sheet, some ABS plastic rod, and cyanoacrylate. So before starting the repair, I did clean down the panel thoroughly to remove any dirt or oils that could impair the repair work. I also taped off the decals, as some of the work we'll be doing potentially could cause damage to the decals, so we want them to be protected. Now the first step here is there's several large cracks that emanate away from the damaged area. And I want to mechanically secure those cracks before we plastic weld them, and also plastic weld in the missing part. To do this, I'm going to use an old school method. So we have some staples that I've bent over into kind of loops there, and I'm going to use the plastic welder to weld these across the crack at various locations across down through the crack. So normally I start by putting one in at the end of the crack. That stops it going any further, and then literally I'll put a staple in probably every 20 millimeters or so. And this is not the final mechanical bond that we'll be using. We will be plastic welding those cracks, but this just gives it extra security, and it keeps the parts of the panel aligned as I'm welding them. So the next step, I'm going to plastic weld the 2 cracks before I actually attempt replacing the part that's missing. That's because I want the panel to be fully aligned when I do that. So the way I generally do these repair these cracks is I take the welding iron and I actually put it on its edge. So the flat plate of the iron, I put that on its edge, and I run that along the crack, applying pressure to it at the same time, and I melt all the way through. As I run it down the crack, I make sure it's melted all the way through to the rear of the panel, so I know I've got a good bond through the entire thickness of the panel. Now when I'm done, I didn't take a photograph of it, but this actually leaves a groove in the plastic along the entire length of the crack, and that's on purpose. What I then do is I take the filler rod, the ABS rod, and using the flat of the iron, I then melt that filler rod into that groove all the way along the original crack, and that then provides very, very, very strong mechanical bond. So I have the 2 parts of the fairing around the crack that were initially welded, and then I weld in filler rod with additional material, and you can see here I actually put in excess material just to make sure that I've got a good bond there. Here I'm using a template for the part that's missing from the panel we're repairing, and overlaying that on the donor panel, and I'll use a Dremel with a cutting wheel to actually remove this piece, and then we'll attempt to weld that piece into the panel we're repairing. So I've roughed out the donor piece, and I'm now going to temporarily fit that to the panel using tape, and I'm going to apply the tape over the outside of the panel, because we're going to lay the reinforcing for this piece on the inside. Because this part of the panel is obviously prone to damage around that Zeus fastener, rather than just relying on plastic welding, which I don't think will be sufficient in this case, I'm actually going to use a reinforcing wire mesh. So I've cut the mesh roughly to the size of the jointing area there, with quite a bit of excess either side, and then I use the hot iron, the flat of the welding iron. I press down on the wire mesh such that it heats up and then sinks into the plastic, so it's being pushed into the plastic, melted into the plastic, both on the main panel and on the donor piece. And I'll actually apply enough pressure on the whole area of the wire meshing such that it'll basically sink to about 50% of the depth of the panel. So the wire mesh will always remain within the panel, within the center of the panel by the time I'm finished, but you won't be able to visibly see it once the repair is complete. So I then flip the panel over, and because the donor part wasn't an exact match with the panel, there's some gaps, and I use the ABS filler rod to just fill in those gaps with the welding iron. And then I do the same repair process to the joint between the donor part and the panel as I used on the cracks. So I take the edge of the welding iron and I run that along the joint area, and I press through, welding the two plastic parts and all the way down through to the reinforcing mesh that I applied from the rear. And then the groove that's left, I use the ABS filler rod again to just fill in that groove. And then that way now I have plastic welding from the back, plastic welding from the front, and of course we have the reinforcing mesh, which is now in the center of all of that. So no matter how good the plastic welding process is, and we've taken obviously great care to make sure that we melt the plastic all the way through the thickness of the panel, there's still voids in those areas. And you know, those voids can cause weakness in the panel and show as hairline cracks at later stages. So we want to address that, and we also want to address obviously the major cosmetic damage that was caused in that area as well when we melted the two plastics together. So this next step is critical in bringing the whole repair together. And the beauty of this process is it doesn't require us to use any bondos or fillers or putties. So for this next step, we're using a very, very thin cyanoacrylate, a super glue, an industrial strength super glue. We're using a hard sanding block and 100 sandpaper. And what we do is we pour the cyanoacrylate into all the areas and around the areas that we've plastic welded, and because it's very thin, it fills in all the voids and it actually penetrates deep into the panel in all the void areas, and in doing so it's starting to bond the plastic within those areas. It's melting the plastic and bonding it, and then while the cyanoacrylate is still fluid, before it sets, we take the sandpaper and the block and we start to sand the surface to a flat finish. What that actually does is, as we're sanding and we're taking off that excess ABS plastic, that gets ground into a dust, and that dust actually also fills all the voids where the cyanoacrylate is laying. So this is the final result of the process. You will need to repeat it multiple times to get to this stage. So you apply the cyanoacrylate, sand it back with the 100 grit paper. You just keep doing that, building up the areas, low areas, sanding down the high areas, making sure all the voids and deep scratches are filled. But you can get to this stage without the use of any body fillers or glazing putties. And the repair is as strong as the original panel. So, and I did repeat the process on the rear of the panel. We want this panel to look as close to OE as possible. So the next stage is to address the cosmetics. So we'll be obviously repairing all the scratches caused in this area by the process itself, and we'll be addressing any cosmetics on the other areas of the panel.